The habitat shelter was tearing free from its moorings when Kael'thas reached the emergency beacon, and the human was holding it down with her bare hands. Not metaphorically, not with tools or equipment. Linda Harris had her shoulder braced against the main support frame, her boots dug into mud that should have been frozen solid, her hands locked around structural points that were visibly bending under the strain. The wind screamed at 270 kilometers per hour. Kael'thas's helmet display confirmed it. And the 3-ton emergency shelter was trying to become airborne with 47 refugees inside. "How long?" Kael'thas started. 9 minutes. Linda grunted, not looking at him. Her arms were shaking. Anchors failed at 0642. "You got rope?" 9 minutes. Kael'thas had seen the structural specifications for these shelters. The emergency protocol stated clearly that once primary anchors failed in winds above 200 kph, the structure had approximately 45 seconds before catastrophic displacement. His people's physiology could maintain a bracing position like hers for perhaps 30 seconds before muscle failure. The human had been holding a building in place for 9 minutes. The magnetic clamps. He tried. Dead. Power grid's gone. I need rope, cable, anything. Linda shifted her weight slightly. The shelter groaned, but didn't move. And tent stakes, big ones. Tent stakes. She wanted tent stakes. For a structure that required alloy anchoring spikes rated for 300-kilometer winds. "I'll call for reinforcement equipment." "No time." Linda's voice was strained, but absolutely steady. "Check your readouts. How many other shelters are failing?" Kael'thas pulled up the camp grid. His secondary heart stuttered. 17 structures showing critical anchor stress. 8 more with anchor failure warnings. The storm was intensifying exactly as Azila had predicted. 6 more hours of this, potentially worse. Medical shelter just went to critical. Habitat clusters 3 and 7 are priorities, Linda interrupted. "Which ones have cubs?" He highlighted them on his display. 6 structures. "Mark them on my heads up. Then get me those stakes. There's construction equipment at my work site, half-kilometer west. Sledgehammers, manual cable spools, industrial stakes." She took a breath that sounded painful. "Move." Kael'thas moved. The construction site was chaos. Wind had scattered materials across 100 meters, but Linda had apparently secured the heavy equipment. He found Vex Thule there, the security chief trying to anchor a supply container that was walking across the ground, despite weighing several tons. "The human sent you?" Vex Thule shouted over the wind. "She needs manual anchoring equipment." "Manual?" Vex Thule stared at him. "The reinforcement drones can't operate in these conditions. Help me load this." They loaded sledgehammers, primitive tools that seemed absurdly heavy, and spools of construction cable onto a cargo sled. The stakes Linda wanted were half-meter lengths of hardened alloy, pointed on one end. They looked like something from a historical exhibit. When they returned, Linda was still holding the shelter. Her hands had gone white where they gripped the frame. Ice was forming in her hair. "Took you 12 minutes, she said. "Okay. Vex Thule, you're stronger than Kael'thas?" "Yes, but good. On my mark, you're going to hold this exact position. 2 hands here and here, shoulder against this support. Don't try to improve it. Don't adjust. Just hold what I'm holding." "The refugees inside," Kael'thas began, "won't die if you move fast. Vex Thule, ready?" The security chief positioned himself, looking dubious. "Now." Linda released the shelter and rolled aside. Vex Thule lunged into position and immediately understood the problem. The force trying to tear the shelter away wasn't steady pressure. It was dynamic, fluctuating, trying to find purchase. Holding it required constant micro-adjustments, reading the wind's patterns, compensating in real time. His arms started shaking in 15 seconds. Linda already had a sledgehammer. She'd identified 8 points around the shelter's perimeter, seemingly at random. The first stake went in at an angle Kael'thas would have called incorrect, but she drove it through frozen ground with 4 massive strikes, the hammer moving so fast it blurred. Cable whipped out, threading through hard points on the shelter frame. Her hands moved in patterns he didn't recognize, complex knots that formed and tightened in seconds. 45 seconds after Vex'thul took her position, Linda said, "Let go." Vex'thul stumbled back, gasping. The shelter strained against the cables and held. The improvised anchors flexed but didn't fail. "That's not possible." Azila's voice came through the comm. The weather specialist had been monitoring. The tensile strength-to-surface area ratio. Those stakes should have pulled free immediately. Linda was already moving toward the next critical shelter. "Angle and depth. I'm using ground compression and load distribution. Where's my next priority?" "Habitat 7, Kael'thas said, pulling up the grid. 32 refugees, 12 cubs. Anchors at 60%. "Show me." They ran, or rather, Linda ran and Kael'thas tried to keep pace. The human was moving through wind that forced him to lean at 45 degrees just to stay upright. She seemed to read the gusts, shifting her path to use buildings as wind breaks, timing her movements between the worst strikes. Habitat 7 was already lifting on one side when they arrived. Refugees were screaming inside, high-pitched distress calls that meant cubs were terrified. Linda didn't hesitate. She grabbed the lifting edge, the entire corner of a 3-ton structure, and forced it back down. Her boots actually dug trenches in the frozen ground as she drove the habitat back to level. "Stakes," she commanded. 6 these positions. She rattled off locations while holding the building with one hand and marking positions on his display with the other. Kael'thas and Vex'thul drove stakes. They managed perhaps 1 strike 2 or 4. The sledgehammers were sized for human strength. But between them, they got the stakes placed. Linda's cable work was faster this time, more efficient. She'd already assessed the load patterns, knew exactly how to rig the structure. 60 seconds. The habitat was secured. "Next," Linda said. They worked through 3 more shelters in 20 minutes. Each time, Linda assessed the structure in seconds, identified optimal anchor points, and secured it with equipment that shouldn't have been adequate. Each time, the cables held despite Azila's calculations showing they couldn't. The medical shelter was different. Liranna's distress call came through as they finished Habitat 12. "Catastrophic failure imminent. Life support systems are static. Then, I can't evacuate them. They'll die in the wind." "How long?" Linda asked. 4 minutes, maybe 5. "We're 2 minutes away. Azila, I need wind vectors on approach." "Sending now, but Linda, that structure is already compromised. The main support frame is cracked, even if you secure the anchors." "Then I'll hold the frame. Send the vectors." They reached the medical shelter as it began to collapse. The main support beam, a reinforced alloy spine designed to bear the entire structure's load, was visibly fractured, the 2 pieces grinding against each other. The shelter was folding in the middle like paper. Linda looked at it for perhaps 3 seconds. "Vex'thul, get everyone away from the north wall. Liranna, move patients to the south side. Maximum distance from me. Kael'thas, you're going to hand me materials exactly when I ask for them." "What are you—" Linda walked into the collapsing structure and braced herself under the breaking support beam. She took the weight of the entire shelter on her shoulders. Kyle Thas heard the frame groan as it settled onto her. Linda's knees bent slightly, then locked. Her hands found purchase points on both sides of the fracture. She was literally becoming a support column, using her body as a load-bearing structure. "Reinforcement strut," she said calmly. "The 1-meter length." He handed it to her. She wedged it into position with her left hand, while her right shoulder took the full load. Her breathing was controlled, steady. "Cable," the heavy gauge. He passed it. She threaded it one-handed, creating a tension system that pulled the fractured beam together. "Secondary strut, horizontal." The shelter was shaking in the wind. Linda wasn't. She locked the second strut into place, forming a cross brace over the fracture. "Binding compound. Spread it on the joint. That takes 30 minutes to cure. It'll hold enough in 5. Do it." Kelthas applied the compound, working around her hands. Linda was supporting easily 3 tons, probably more with the dynamic wind load. Her muscles were rigid, her breathing slightly elevated but not labored. 3 more minutes, she said. "Lirana, status on patients?" "Stable, but you can't." 3 minutes. "Azila, what's the wind pattern looking like?" "Sustained at 290, gusts to 320. This is the peak intensity. It should start declining in 40 minutes. "Good. Means we have time for the rest." "Kelthas, when I say now, you're going to place stakes at these points." She highlighted positions on his display. "Don't argue about locations, just put them where I mark. You can't hold that much longer. I can hold it 6 more minutes. We need 3. Stakes ready?" He positioned them. Vex Thule had the sledgehammer. "Now." Linda shifted her stance slightly, somehow taking even more weight to keep the structure stable while they worked around her. The compound was starting to bond. The temporary struts were holding. Vex Thule drove stakes with desperate speed. "Cable routing," Linda said, and began describing a rigging pattern that would distribute the shelter's load across 8 anchor points instead of the original 4. Kelthas threaded cable while she held tons of weight on her shoulders, as casually as someone waiting for transit. 2 minutes 50 seconds after she'd walked into the collapsing structure, Linda said, "Compound set enough. Transferring load to anchors in 3, 2, 1. She stepped out from under the beam. The shelter groaned, settled 6 centimeters, and held. The improvised support structure flexed, but didn't fail. 30 refugees with critical injuries remained stable inside a building that shouldn't have survived. Linda rolled her shoulders once, picked up her sledgehammer, and checked her display. 14 more critical structures. 5 hours, 40 minutes until wind decline. Let's move. "You need rest." Lirana started. "I need to finish the job. Show me the next one." They worked through the camp systematically. Linda developed a rhythm, assess structure, mark anchor points, drive stakes with mechanical precision, rig cables using knots Kelthas had never seen. Sometimes she held shelters while they worked. Sometimes she braced collapsing frames long enough to evacuate refugees to stronger buildings. 3 hours into the storm, Vex Thule asked the question Kelthas had been thinking. "How are you doing this?" Linda was driving her 47th stake. He'd counted and didn't pause. "Construction sites are controlled disasters. You learn to work through chaos." "Strike. Hurricane season back home, we'd prep sites knowing storms were coming." "Strike. You build assuming failure." "Strike. Then you fix the failures in real time." "But the physical capability. Earth gravity's heavier than here. I'm working at 85% my normal weight." She finished the stake, moved to the next position. "Plus, this isn't that bad. Try placing rebar. in 40-degree heat with 100K wind from sandblasting. 100-kilometer winds aren't construction site weather. It's just wind and cold. She started the next stake. The complicated part is reading the load patterns. You see how this shelter's trying to rotate? That means the primary stress is torsional, not lateral. So the anchors need to prevent rotation, not just resist wind force. She was teaching, while saving their camp, while doing things their equipment couldn't accomplish. Your automated systems, Linda continued, moving to the third stake. They're designed for optimal conditions. When conditions go bad, they fail. Human construction evolved through failures. Every technique I'm using comes from something that broke and killed people. We learn by disaster. Efficient, Vexthul said quietly. Brutal, Linda corrected. But effective. Your anchors failed because they assumed the ground would behave predictably. Ground never behaves. Soil compression, frost heave, water table shifts. You design for the chaos, not the plan. She finished the anchor pattern, tested the cables with pulls that would have dislocated Kael'thas's arms, and nodded. Next. By hour 5, every critical structure was secured. Linda had worked through the entire priority list, supplemented failing tech anchors with manual backups, and created a hybrid system that combined their technology with her construction techniques. When the wind finally began to decline, Linda was rechecking her work, walking from shelter to shelter with a critical eye. She adjusted tensions, reinforced 2 anchor points that showed wear, and made notes on her display about permanent improvements. Kael'thas found her at Habitat 7, testing cable tension. Casualty report just came through, he said. 0 deaths. 17 minor injuries from falling equipment. No structural losses. Good. Linda moved to the next cable. You'll want to replace these manual anchors with proper installations when weather clears. And upgrade your emergency protocols. Manual backup systems should be standard. I contacted regional coordination during hour 3, Kael'thas admitted. Told them what was happening. They asked if they should order you to stop. Linda looked at him. What did you say? That you were the only thing working. He paused. They've given me emergency authority to implement any changes you recommend. Smart. She finished her inspection, shouldered her sledgehammer. Okay, recommendations. 1. Stock primitive tools at every camp. 2. Train your security teams in manual anchoring. 3. Stop assuming technology won't fail. 4. Get comfortable with chaos-based planning. Will you help implement these changes? Linda checked the time. Can't. I'm 16 hours behind on the commercial site foundation. Storm put me way off schedule. Azila arrived at the camp center with a portable analysis suite and an expression that suggested her worldview was undergoing structural failure. I need to understand the mathematics, she said without preamble, setting up her equipment next to the first shelter Linda had secured. Your anchor points shouldn't work. The force distribution models show failure within seconds, but they've been holding for 6 hours. Linda was coiling cable, preparing to return it to the construction site. What do your models assume about soil compression? Standard density calculations based on composition and temperature. There's your problem. Linda walked to the nearest anchor point and tapped it with her boot. You're calculating what the soil should do. I'm reading what it's actually doing. She knelt, brushed frost from around the stake. See this discoloration? That's clay content. Clay compresses differently when frozen versus thawed. Your stake was designed for consistent density. Mine's angled to account for the clay layer binding tighter under pressure. Azila scanned the anchor point, But how did you know the clay was there? Drainage pattern around the shelter. Water pools northwest, which means lower permeability there. That's clay. Southeast has faster drainage, sandy composition. So I anchored heavy on the clay side, used the sand side for lateral stability. Linda stood, moved to the next stake. Every position accounts for what the ground actually is, not what the survey says it should be. That's not possible to calculate in real time. I'm not calculating, I'm reading. Linda pointed to slight variations in ground color, frost patterns, the way mud had dried around shelter bases. 20 years on construction sites. You learn to see what the ground's telling you. Vexthul joined them, reviewing security footage on his data pad. I've been analyzing your movement patterns during the crisis. You were consistently choosing routes that shouldn't have been optimal according to wind vector models. Because I wasn't following wind vectors, I was following wind shadow and pressure zones. Linda gestured at the camp layout. Buildings create turbulence patterns. Your models show average wind speed. I was reading where the wind actually weakened, moved through the gaps. She pulled up a map on her display, marked her paths. Here, the wind hit 2 structures and created a low-pressure zone. Here, the gap between shelters accelerated wind speed, so I went around. Your vectors are mathematically correct but practically useless. Reality's messier than models. Azila was running calculations, her secondary hands moving frantically across her equipment. If I adjust for real-time soil variance and micro-terrain features, she paused. The computing power required would be immense. You're saying you do this instinctively? I'm saying I do this through experience. Computers calculate. Humans recognize patterns. Linda finished coiling the cable. Every site I've worked had different soil, different weather, different failure modes. You see enough disasters, you start recognizing the signs before they become disasters. Kael'thas had been listening from the shelter entrance. Your emergency response philosophy is fundamentally different from ours. We plan to prevent disasters. You plan to work through them. Both have value, Linda said. But yeah, human construction assumes things will go wrong. Equipment fails, weather changes, ground shifts. You build in redundancy, train for chaos response, keep manual skills sharp. She hefted the sledgehammer. Technology's great until it isn't. Then you need somebody who knows how to drive a stake by hand. I need to test something, Azila said abruptly. She highlighted a shelter that had survived on original anchors. This structure experienced identical wind loads to the ones you secured. Can you assess why it held? Linda walked the perimeter, examining anchor points, testing tensions, checking the ground. Lucky placement. It's sitting on bedrock 6 inches down, anchors hit solid substrate, and it's positioned in a natural wind channel that reduced lateral loading by maybe 15%. She pointed to subtle terrain features. The refugees who placed this probably didn't know why they chose this spot. But humans have instincts about safe locations. Thousands of years of evolution building shelters in dangerous places. Instinct, Vexthul repeated. You're saying your species evolved disaster response as a survival trait? We evolved on a hostile planet with extreme weather, tectonic instability, and megafauna that wanted to eat us. Linda shrugged. Yeah, we got good at surviving disasters. It's why we over-engineer everything, maintain redundant skills, and stay functional when conditions go to hell. She checked her display again. Speaking of which, I really need to get back to work. Foundation pour is scheduled for tomorrow, and I haven't finished the rebar grid. Wait, Kael'thas said. I need to contact regional coordination about implementing your recommendations. They'll want specifics. Linda sighed, set down her equipment. Okay, specifics. First, manual tools. Every emergency cache should have sledgehammers, pry bars, cable, and stakes. Not as primary equipment, as backup. When power fails, you need something that works without electricity. She pulled up a schematic on her display. Second, training. Your security teams are strong enough to drive stakes if they learn proper technique. It's about momentum and accuracy, not just strength. I can run a workshop. 4 hours should cover basics. 4 hours to learn what you do? Vex Thule sounded skeptical. 4 hours to learn emergency anchoring. What I do took 20 years. But basics? Anyone can learn basics. Linda marked positions on the schematic. You won't be as fast or efficient, but you'll be functional. That's the point. Functional beats optimal when optimal isn't available. Azila was still running calculations. I'm trying to model your decision-making process. The variables you account for: soil composition, micro-terrain, wind shadow, structural load patterns, material stress. The processing required should take hours. You complete assessments in seconds. Because I'm not processing variables. I'm pattern matching. Linda walked to a nearby shelter, placed her hand on the frame. Feel that vibration? That's wind loading creating harmonic resonance in the support structure. It's within tolerance now. But if wind increased another 50 km, you'd get stress fractures. I don't calculate the physics. I recognize what dangerous resonance feels like. She moved to another structure. This one's solid. No vibration, loads evenly distributed, anchors are stable. I don't need instruments to tell me it's safe. I can feel it's safe. Tactile assessment, Lirana said, joining the group. She'd been treating minor injuries, but looked fascinated. You're using sensory input that our equipment doesn't measure. Equipment measures what you tell it to measure. I'm measuring everything. Linda tapped her temple. Sound, feel, visual cues. How materials respond to pressure. It's holistic assessment, not data collection. Kael'thas received a communication alert. Regional coordinator wants a direct report. He paused, reading. They're asking if we should implement camp-wide protocol changes based on your methods. Absolutely, Linda said. Your current protocols assume technology works. They need to assume technology fails. That means manual backup systems, trained personnel, and stockpiled primitive tools. Primitive, Vex Thule repeated. Our ancestors abandoned manual tools 8,000 years ago. And lost critical skills when you did. Linda picked up her sledgehammer. This is older technology than your ancestors used. But it works when fusion power fails, when automated systems crash, when optimal conditions become survival conditions. Evolution doesn't care about efficiency. It cares about what works when everything else doesn't. She demonstrated a proper stake driving technique, the hammer moving in controlled arcs. See? Momentum does the work, not strength. Let gravity help. Aim for consistency, not power. 4 strikes per stake, same angle every time. Your security teams can learn this. Vex Thule tried it. His first 3 attempts were awkward, but the 4th stake went in cleanly. This is not difficult, just unfamiliar. Exactly. Unfamiliar isn't impossible. Linda handed him the hammer. Practice 50 stakes, you'll be functional. Practice 500, you'll be competent. Practice 5,000 like I have, you'll be expert. But functional happens fast, that's why it's valuable. Azila finished her analysis. I've modeled the camp using your assessment methods. If I account for actual soil behavior, real-time terrain features, and dynamic loading patterns. She looked up, disturbed. Our original anchor placements were suboptimal in 43% of installations. We didn't account for ground truth, only design specifications. Design specs are starting points, Linda said. Ground truth is what actually matters. You can't survey soil from orbit. You need hands in dirt, eyes on terrain, people who recognize when reality doesn't match blueprints. Kael'thas was composing his report to regional coordination. They're going to ask why this wasn't identified in planning phases. Because planning assumes ideal conditions. Reality provides actual conditions. Linda checked the time again. Look, I need to move. But recommendations are simple. Require manual skill training for emergency personnel. Stock backup equipment that doesn't need power. Teach people to read ground conditions, not just truss sensors. Build redundancy into everything. They'll want you to oversee implementation, Kael'thas said. Can't. I build foundations for commercial structures. That's my job. Linda started loading her equipment onto a cargo sled. I'm happy to consult, run that workshop, review protocol updates, answer questions. But I'm a construction worker, not a policy specialist. Lirana stepped forward. The medical shelter would have collapsed without your intervention. 30 lives saved because you recognized structural failure before our monitoring systems did. That's not just construction work. That's emergency medicine applied to buildings. That's recognizing when a support beam's about to fail. Linda corrected. Same skill I use placing foundation supports. The application's different. The assessment's identical. I see load distribution and stress patterns because that's my profession. You don't need me specifically. You need people trained to see what I see. But training takes time. Azila started. Then start now, Linda said. Emergency response isn't about preventing disasters. It's about functioning during disasters. Every day you don't train manual skills is a day you're vulnerable when technology fails. She finished loading equipment, secured it against residual wind. Workshops tomorrow if you want it. Early morning before my work shift. Beats, bring your security teams, anyone who might need emergency response skills. I'll teach basics. Why would you do that? Vex Thule asked. This isn't your responsibility. Linda looked at him like he'd asked why water was wet. Because you need to know this stuff. Because next storm might hit when I'm not here. Because skills that keep people alive shouldn't be restricted to one person. She shrugged. Besides, teaching's easy. You just show people what works. Kael'thas sent his report, flagged it urgent. Regional coordination acknowledges. They're implementing immediate changes. Manual equipment procurement authorized. Protocol revision in progress. Training requirements approved. They're asking if you'll consult on refugee camp standardization across the sector. Sure, if it doesn't conflict with work schedule, send me specs. I'll review them. Linda climbed onto the cargo sled. Anything else urgent? Just... Kael'thas gestured at the camp around them. Thank you. For the lives saved, the structures preserved. For showing us our assumptions were wrong. Linda started the sled. Your assumptions weren't wrong. They were incomplete. Technology's great, planning's valuable, but reality's messy, and humans have 12,000 years of experience working through mess. Use both. Plan for optimal. Prepare for chaos. She paused, looking back at the camp. Shelters standing solid, refugees safe, manual anchors holding against a storm that had defeated advanced technology. You know what construction workers say? Perfect's the enemy of done. Your systems aimed for perfect. Perfect failed. I aimed for done. Done worked. Remember that when you revise protocols. The sled hummed to life. Linda drove toward her construction site, leaving behind aliens examining sledgehammers and rope like they were revolutionary technology. Which, Kael'thas supposed, they were. 4 days later, the first manual response training workshop had 300 applicants. Linda ran it before her work shift, teaching stake placement and cable rigging and ground assessment. Her students were clumsy at first, but competent by hour 3. Vexthul became her assistant instructor, demonstrating techniques for their physiology. Azila developed monitoring protocols that incorporated manual assessment points. Lir'ana created medical emergency procedures, assuming structural response teams with human-style training. Regional coordination implemented camp-wide changes. Every facility received manual equipment caches. Emergency protocols now included technology failure scenarios. Training requirements specified hands-on skills, not just systems operation. 2 weeks after the storm, another weather emergency hit a camp 400 kilometers north. Their automated systems failed. Their manually trained response teams secured critical structures using Linda's techniques. 0 casualties. Kael'thas received a commendation for innovative crisis response. He forwarded it to Linda. She replied, "Nice. Can you send that sledgehammer back? Need it for foundation work." 3 months later, refugee camps across 6 sectors had implemented the protocols. Harris standards, they were called. Manual backup systems, chaos-based planning, skills training over technology dependence. Linda finished her foundation pour on schedule, moved to the next construction site, and taught weekend workshops when requested. She turned down 4 consulting positions, 1 emergency response directorship, and a systems analysis role that paid triple her construction salary. "I build things," she explained to Kael'thas when he asked why. "Consulting's just talking about building things. I'd rather do the actual work." The actual work saved 600 lives during the storm season, he pointed out. The actual work was securing shelters so I could get back to pouring foundations. She was reviewing specifications for a new commercial complex, marking structural concerns. "Though, I'm glad the workshops helped. Good to know other people can handle emergencies now." "You don't see yourself as exceptional," Azila observed. She'd been studying Linda's assessment methods, trying to develop training simulations. "I'm a competent construction worker with disaster experience." Linda highlighted a concern on the blueprints. "Exceptional would be doing this without training. I've got 20 years of training, that's just professional skill. 20 years of training in conditions that would kill most species," Vexthul said. He'd adopted manual tools for security operations, found them surprisingly effective. "Earth's not that bad. Little weather, some tectonic activity, occasional wildlife issues." Linda sent her specification review to the project manager. "You adapt, or you don't survive. Humans adapted. That's evolution, not exceptional." Kael'thas received another message from regional coordination. They wanted Linda's input on colony emergency protocols. They're expanding implementation beyond refugee camps. Permanent settlements, research stations, industrial facilities. Everyone wants Harris standards. "Tell them to read the manuals," Azila wrote. She documented everything better than I could explain it. Linda stood, collected her work materials. "I've got rebar placement starting in an hour. You need anything else?" "Just..." Kael'thas searched for words. "Acknowledgement that you revolutionized our emergency response philosophy." Linda laughed. "I taught you to use sledgehammers. That's not revolution. That's remembering old skills." She headed for the exit, paused. "Though I guess if you forgot those skills, remembering them probably feels revolutionary. Perspective's funny that way." She left them there. contemplating sledgehammers and rope, and the fact that their most advanced emergency response innovation came from a construction worker who thought extreme weather was just another work condition. Azila ran another simulation, incorporating human-style pattern recognition and chaos-based planning. Results showed 63% improvement in crisis survival rates. "We spent 8,000 years advancing past manual tools," she said quietly, "and lost the skills that matter most when advancement fails." "Humans never advanced past manual tools," Vexthul observed. "They just added technology on top of foundational skills. We replaced foundation with technology." "Different evolutionary pressures," Kael'thas said. "We evolved on stable worlds with predictable conditions. They evolved on a planet that actively tried to kill them. We optimized for efficiency. They optimized for survival." "And survival," Azila concluded, watching Linda's cargo sled disappear toward the construction site, "beats efficiency when conditions become hostile." Somewhere in the distance, they heard the rhythmic sound of a sledgehammer striking stakes. Linda, preparing her next work site, using 12,000-year-old technology to secure equipment against weather that might come. Planning for chaos, building for survival. Just another day of actual work.